Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a nice problem with complex numbers. What is this problem about? Well, we're given that z, which is a complex number, satisfies the following equation: z squared minus z plus 1 equals 0. And then for those values of c, we are supposed to find or evaluate z to the fifth power plus 1 over z to the fifth power. So I'll be presenting at least two methods, and one of the methods may be a little longer than other. But what is a complex number? A complex number can be written as a plus bi, where a and b are real numbers and I is the square root of -1. And it's also the name of this channel, right? A plus bi. Hopefully you know my other channel where I do algebra and number theory problems, and maybe that's where you came from. If you did, thank you. Welcome to this channel. It's called Cyber Math. Cyber with an S. All right, great. So let's go ahead and talk about it. Now, we can go ahead and first use the first method. Sometimes I use the second method first, and some people call it the first method, but that's wrong. But anyways, that's a different story. Now, to be able to solve this problem, I kind of need to know the value of z, right? Let's just say right for now. So we can go ahead and solve for z and then just plug it in. It should be easy, right? Well, if only we could find an easy solution. Well, it's easy, but you'll see. So how do you find the solution from here? You can just solve the quadratic formula using the quadratic equation using the quadratic formula. Negative b plus minus the square root of b squared, which is 1 minus 4. That's a -3. We got the square root of a negative number. What is that? It is an imaginary number, which can be written as root 3i. Okay? With the plus minus sign, everything is taken care of. We have two solutions. But which solution are we going to use? The answer, it doesn't matter. That's how the problem is structured. Get the idea? So I'm going to use the more positive one, which is this one. Great. So what I'd like to do with this one is I want to raise it to the fifth power, right? Do you really want to do that? Maybe, for now at least. To find z to the fifth power, basically we need to raise this fraction to the fifth power. But how do you raise a fraction to the fifth power? You raise the numerator to the fifth power, and then you can raise the denominator, which is 2 to the fifth, which is 32. Now, for the numerator, which is the new numerator, you can use the binomial theorem, but that will be long. That will be 6 terms. You're going to have to deal with powers of I, powers of square root of 3. That's way too much work. So we could probably do something nicer, which is the following. 1 plus root 3i can be written as an exponential, thanks to Euler, okay? So we can go ahead and write it as follows. I'm not going to show you all the details, but first you need to find the absolute value of 1 plus root 3i, which is 2. And then you'll put that first, and then there's an angle that allows us to write this in polar form. And that angle is actually determined by the real and imaginary values. In this case, that happens to be 60 degrees or pi over 3 radians. So we can now write it as 2 times e to the power I pi over 3. And this is the principal value. You can obviously add multiples of 2 pi to this. That's not necessary for our purposes, because all I have to do is raise it to the fifth power. It would not matter. All right? So let's go ahead and take this to the fifth power. We have 2e to the I times pi over 3, and then I got to raise it to the fifth power. That would give me 2 to the fifth power, again, 32, and then times e. And by the way, I didn't have to do it this way. I could directly raise this. That's another approach, but let me just do it this way. That would give me e to the power I times 5 pi over 3. Okay, great. So now, what is this value equal to? Now, Euler's formula, again, comes to the rescue, which gives us e to the I theta equals cosine theta plus I sine theta. By the way, if you're new to complex numbers and don't know these formulas, go ahead and check out my lecture videos. Okay? Great. And if you have any questions, always feel free to let us know. Now, this is the value, but so the next thing I need to do is evaluate cosine and sine 5 pi over 3. What is 5 pi over 3 though? quickly on the unit circle, if you think about it, 5 pi over 3 is equivalent to 300 degrees. That's how I usually do it, like convert real quick. 300, or you can think of it this way too. It is kind of like a pi plus 2 pi over 3. So I don't know if 2 pi over 3 would be very clear to you, but pi over 3 is 60 degrees, so that's probably the easiest way to go. And 300 is 270 plus 30, so something like this, okay? If I look at the sine and cosines, this is supposed to be a negatively large value. This is supposed to be 1/2. It's about the middle, but it's not exact. Of course, in this picture, you can tell, hopefully, or if you memorize the values, you should know this. So cosine is 1/2, and sine is root 3 over 2, but with a minus sign. Make sense? So should that be the answer? Well, looks like it, but notice that the 32 is going to cancel out. And by the way, have you noticed that? Well, here, we'll get a 32. So it's going to be like this. 32 times 1/2 minus I times root 3 over 2, and then divide by 32, and they're going to cancel out. So that should be the answer, but this is just z to the 5th power. Then I need to find 1 over z to the 5th power, which is the reciprocal of this, but since its modulus is 1, check y, then it should just be the reciprocal, the conjugate. So when you add these up, 1/2 minus I times root 3 over 2 plus 1/2 plus I times root 3 over 2, the imaginary parts are going to cancel out, and we're going to end up with 1/2 plus 1/2, which is 1. Wow, really? The answer is 1. We did all this work for 1. Well, we did, but this is why we have the second method, okay? Awesome. So let's go ahead and take a look at the second method. What were we given? Z squared minus z plus 1 equals 0. Now, there's a couple ways to go about it. Let me give you both. So kind of like 2a and 2b. And I got to say, 2b or not 2b, I always make that joke, and some people don't like it. I know that, but some people like it, so I continue. Now, with the 2a, we're going to go ahead and do the following. We will turn this into the following, like I will isolate z squared, and then I want to get to the z to the 5th power, right? So I want to multiply both sides by z. Z cubed is going to be z squared minus z, but I know that z squared is z minus 1, so this is z minus 1 minus z. Z cancels out, and z cubed becomes -1. That's good. Z to the 4th is just going to be negative z, and z to the 5th is just going to be negative z squared. By the way, you could directly multiply both sides by z squared to get z to the 5th quicker, which is probably a good idea. So let's do that, which will be negative z squared. But since z squared is z minus 1, z to the 5th would be 1 minus z, which is the opposite. What about 1 over z to the 5th? We can do that next. Okay, now let's go ahead and write this, and then write that. And now I'll make a common denominator. That'll be 1 minus 2z plus z squared plus 1 divided by 1 minus z. You got to remember, z squared can be written as z minus 1. So minus 1 and plus 1 will cancel out. We're going to have 1 minus z over 1 minus z, which is 1. So the answer is 1 from here. Awesome. Let's take a look at the 2b or not 2b method. With this method, I kind of use something smart. So think about it this way. If you multiply both sides of this equation by z plus 1, 0 is unchanged. But we introduce an extraneous solution, which is z equals -1. And we shouldn't accept it because it's extraneous. Make sense? So from here, we get z cubed plus 1 equals 0. Beautiful. And this gives us z cubed equals -1, which means we're dealing with the cube roots of -1. I hope you know what I'm talking about. And then this brings us to the same point. The rest is pretty much the same, but this is 2b or not 2b. Sorry, I said it too many times. But from here, we get that the answer is always 1. So the idea was not to solve for z, actually, but it was more like, can you use identities to evaluate this real quick? So the answer is 1, but z is not real. Remember that, okay? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and don't forget to check out Cyber Math. And bye-bye.